Hey everyone, in this video what we're going to do is figure out what the limit is as x approaches 0 of tangent of x divided by x all raised to 1 over alpha multiplied by x squared. Now in this example, alpha is just a real number and alpha does not equal 0. So we can begin by rewriting the limit in the following form. E raised to the limit as x approaches 0 of the natural logarithm of tangent of x divided by x all divided by alpha multiplied by x squared. Now, these two expressions are equivalent because e raised to the natural logarithm of x is just equal to x, and all we've done is moved the limit inside the exponential function as the exponential function is continuous, and used the power rule for the natural logarithms to bring the power down to the front. So if we were to just let x tend to 0, in the numerator we would have the natural logarithm of the limit as x goes to 0 of tangent of x divided by x. Now this is just equal to 1, so we would just have the natural logarithm of 1, which is equal to 0. And of course, in the denominator, we would just have the limit as x goes to 0 of alpha times x squared, which is equal to 0. So we have a limit of the form 0 over 0. And in order to evaluate it, we're going to have to use something called L'Hopital's rule. L'Hopital's rule basically says that if you have a limit as x approaches some value c of a function f of x divided by another function g of x, then that limit is equal to the limit as x approaches c of the derivative of f of x divided by the derivative of g of x, given that f and g are both differentiable at c and that they're of indeterminate form 0 over 0 or plus or minus infinity over plus or minus infinity. Now that criteria is satisfied for this problem right here, so let's go ahead and apply L'Hopital's rule to it to try and solve it. And I should have also said that we can apply L'Hopital's rule indefinitely as long as the criteria which I've just mentioned is satisfied. So we're going to have e raised to the limit as x approaches 0. Now we can find the derivative of the numerator by using the chain rule. The derivative of the natural logarithm of some function is just 1 over that function, so we just have 1 over tangent of x divided by x. And this is multiplied by the derivative of the inside part, which we can find using the quotient rule. So we have x multiplied by secant squared of x minus tangent of x divided by x squared. And this is divided by 2 times alpha times x. We can tidy up our expression. Doing so, we have e raised to the limit as x approaches 0 of x multiplied by secant squared of x minus tangent of x divided by 2 times alpha times x squared times tangent of x. Now, if we were to just let x go to 0, in the numerator we would have 0 minus 0, which is of course equal to 0, and in the denominator we would just have 0. So our limit is of indeterminate form 0 over 0, and we can apply L'Hopital's rule again to try and solve it. Doing so, we have e raised to the limit as x approaches 0 of secant squared of x plus 2x times secant squared of x times tangent of x minus secant squared of x, all divided by 4 alpha x times tangent of x plus 2 alpha x squared times secant squared of x. These two sum to give 0, and if we let x tend to 0, in the numerator we just have 0, and in the denominator we also just have 0. So our limit's of indeterminate form 0 over 0, and we're going to have to apply L'Hopital's rule for a third time in order to solve it. Notice we can actually cancel a factor of x, and now we can rewrite our limit as e raised to the limit as x approaches 0 of 2 times secant squared of x times tangent of x divided by 4 times alpha times tangent of x plus 2 times alpha times x times secant squared of x. So applying L'Hopital's rule, we just have e raised to the limit as x approaches 0 of 4 times secant squared of x times tangent of x times tangent of x plus 2 times secant squared of x times secant squared of x divided by 4 alpha times secant squared of x plus 2 alpha times secant squared of x plus 2 alpha times x multiplied by 2 times secant squared of x times tangent of x. Now this term would go to 0, this term would just go to 2, this term would also go to 0, and this term here would go to 2 alpha, and this term here would go to 4 alpha. So we would be left with e raised to 2 divided by 4 alpha plus 2 alpha is just 6 alpha. So we're left with e raised to 1 over 3 alpha. And that's the final answer to this problem. Thank you very much for watching. I hope you found this video useful. If you did, could you please make sure to like and subscribe, as it really does help the channel out. I hope you have a great day.